Hi guys, welcome to part 3 of our machine learning comparison series. I'm Chidi, and in this episode we are diving deep into one of the most critical stages of any artificial intelligence or machine learning project, which is data preprocessing. So whether you're working with the image data sets or CSV tables, your raw data isn't ready for training yet until it is preprocessed. So in this tutorial, I will walk you through how we will process your data by resizing and normalizing images for computer vision, clean and preprocess our tabular data for machine learning, and why these steps are absolutely essential for getting accurate and reliable models. So let's get started. And now we'll be discussing the tools which we require for image or table preprocessing. First and foremost, for image-based projects, to preprocess our image data sets in Google Colab or any workspace you are using, we use a very powerful utility tool which is called the ImageDataGenerator, which is from Keras library. What this does is it helps us to rescale our images, apply real-time augmentation, and also split them into training and validation sets. So I'll show you sample code of such. This is a sample of a code written to preprocess our image. I will explain what each line of code does so you can get the details of what is really happening here. So first of all, what we do is that we first rescale the images to normalize the pixel value between 0 and 1, because we want the pixel values to be between 0 and 1. So the first thing we do, we rescale. It is very vital that you rescale. The two major elements of this code for this train data gen in this area, in this first bracket, is this rescale and validation split. Others are not really compulsory, like rotation range, zoom range. You can choose to delete these ones. You can choose to not to specify them. But what is really important in this is that you need to specify a validation split and a rescale. Also, the next thing we do is that once we specify our rescale to be between a value of 0 and 1, we then split our images into training and validation sets. This is the training set and this is the validation set. So this variable here, which is this flow underscore directory, what it does is a function. It automatically reads the images and assign labels based on our subfolder names. Typically, tabular data are stored in CSV files or spreadsheets. So we use Pandas. We use Pandas library to load, inspect, and also split the data into features and label them. For us to preprocess our tabular data sets, we use Pandas library. So the first thing we need to do is to import Pandas as PD. Remember the last time when we were working with images, what we actually used was Keras library. You can see it's from Keras library. We now use the ImageDataGenerator. But in this case, we're working with tabular data set or CSV file or any spreadsheet for our prediction model as our data set. So we need to import, we use the Pandas library. So we import Pandas as PD. So you also import this string test split because you're using it at the end of the code. So once you've imported it, the next thing you do is to link to the paths. You link to the paths where the CSV file is stored. Probably it's stored in Google Drive. So you link to the file, to the path where it's stored. So this line of code is for us to read that particular file. Why this line of code is for us to print out to show it in Google Colab, to show it in Google Colab or any other platform you're using. So the next thing, once we've done that, is for us to select our input and output features. So in this case, you see that we selected boys and girls. Probably the table has colors for boys, girls, and total number of students. So we say the input features are the boys and the girls, and the output features are the total number of students. We import Pandas PD as the first library we need. Then the next thing is from Scikit-learn model. Scikit-learn.model selection. We should import train test splits. Import train, as you can see, import train test splits. Good. So once we've done that, the next thing we need to do is to define our future. Okay, let's read. We need to load and read our data sets. Understand me? We need to update the part. I know the part is already here, but we need to re-update it in this particular frame. So in this particular frame, so that we can link perfectly to it. So how do that? We define that using df equal to pd. As you can see there, it's already written pd dot read dot csv. This is how we define our part. So our CSV, the part to our CSV, we already defined that initially. There's a part of our CSV. We can just call CSV part because we already stored this inside this variable called CSV parts. So we can just call CSV part here, CSV parts. Then once we've done that, the next thing we do is to define our features. What do you want to be our input and what do you want to be our output? The input is usually S, while the output is usually Y. Let me give a space so it will be plain. The input will be X, while the output will be Y. So as you can see, the input is S is equal to df, open our brackets, we specify the inputs, the first input, and then we specify the second input. That means if I enter a value of frequency and a value of maybe location, it should predict an output for the modulation, a type of modulation. So, or I can say let my input be modulation and frequency, and it should predict the kind of location for me. So in this case, let me say, okay, let me use frequency and location as my input. So I have to specify them here. Frequency from the table, you specify this from your table, and location. These are my input S value. They also specify your output, which is Y. So the output Y, same thing you repeat, df. Let's say the output will be, what do we need for our output? What do we use for our output? Okay, we're operating modulation. So modulation, remember it's in capital letters. It's in capital letters, so our output is what? Modulation. Modulation. So we've completed that. We define our input and our output. Output is what we want to predict. Input is what parameters will help us predict that output. That means if we enter frequency and location based on the data for the previous data for frequency and location, they can predict the next possible modulation. So once we've done that, what we need to do is to split into training and testing. We can choose to use 70% of data for our training and 30% of our data for testing. What that means that, okay, if there are like 10 rows here, if there are 10 rows, row 1, row 2, row 3, row 4, row 5, and we want to use 70% of our data for training, it means to use 7 of these rows to train. 7 of these rows, if you take them, it use them for training. And the remaining 3, it will use them for testing. But if you want to run a training, a validation, and a testing, in 100%, we can say 70% for training, 15% for validation, and 15% for testing. Or we can just use training 50%, validation 25%, testing 25%, making it 100. So, but in this case, I'm going to use 70% for my training and 30% for my testing. So, like I said before, 70% for training means it will use, if these are like 100, if this has 100 rows, 70% training means that you use 70 of the rows for training, 70 of the row data, these data in the rows for training, then you use 30 to test. So let's define that in our code. You can see it's already written for us, like a sample of what we need. So random state is 42. So by specifying our test size as 0.3 means we're using 30% for testing and 70% for training. So as you can see, this is just the code for us to complete our data preprocessing. Like I said initially, the first thing is for you to load your data sets, which we've loaded. Then the next, while we'll link to the part of data sets, then the next thing for us to split into training and testing set, which we've done. So if we run the code now, run the code to see if it is successful. Executing 6 seconds. You can see good. So this is very good. So we're done with this. Okay, now that we've successfully completed for tabular data, our pre-processing for our tabular data, now let's go to that for image sets. So now for the data set of images, for us to pre-process our data, the first thing to do is to load our data. We load the data. Initially, this is the part of our data which we use in the step 2 of our projects, which was data collection. By linking to this, we've linked to this, then we also link to this. Now, because I will find 70 images inside this Google Drive data sets, which I got from my drive inside, okay, from tutorial. This dog and cat data set has 2 subfolders containing a total of 70 images, which we've linked. Now, for us to complete this pre-processing, the first thing we need to do is to import this image generator. We import image generator from this Keras library. So once we define that, the next thing we need to do is to specify the image generator, specify our rescale size so that to help it be within 0 and 1. Then now we're specifying that our validation split is 20%, is 0.2. Validation means we'll be using 20% of the images, of the total images. Remember we had, when we ran this code, we got 70 images belonging to 2 classes. That means that there were 70, or there are 70 images inside these 2. Total of both of them are 70. From those 70 images, we'll be using 20% of those images. Like 20% of the 70 images will be used for validation, while we're using 80% for training. So the next thing we need to do is specify our parts. We need to link to our, or define the part to our data set again, which is this part which we've defined initially. This part to our data sets. We need to show it because we're using another frame. But if we're using the same frame, there won't be any need to define again twice. You have to just copy the line of code and place it after this one, and it works. So you can see that to load our training image, the first thing we do is to load the train generator. If you run this code, they tell you that you have 56 images belonging to class 2 because we're using 80%, and 80% of 70 is 56. So that means 56 images will be used for training. And if we want to specify our validation, what you need to do is simply to, let me copy the line of code because of time. These are validation sets, which we've defined to use how many? 20% of our data set or our images. So if we run this again, you see, we found the first one. For this one, we got 56 images, while for this one, we got 14 images. So you saw the code is working perfectly. So at this stage, we've completed our data preprocessing. In conclusion, preprocessing is one of the most important stage or important step in your machine learning projects. So in our next video, I will show you how to build the model architecture, the architecture of our model.